So this should be a fairly short video, just kind of going through the overall equations for what happens in the light reactions. And even though I have dark reactions here, let's go ahead and let's make that change and say we're not going to call them the dark reactions. We're going to call them the light independent, because otherwise it can get really confusing and it makes it seem like something happens when the sun is out and something happens when the sun is not out. But all of these reactions must be happening and coupled when the sun is shining. Okay, so let's first look at what we're going to call the light reactions. So that's this chemistry that we're going to have right here. Okay, so I'm going to write an equation down below here that sort of summarizes everything that's happening there. We're going to have 2 molecules of water plus light energy, okay, is ultimately going to lead to molecular oxygen, NADPH, and then ATP. So just refreshing our brains for how this all happens. Water is oxidized, okay? So water is oxidized. That's how we generate molecular oxygen. So this is an oxidation reaction. And what we do is that oxidation is the loss of electrons. So those electrons are going to be bombarded with light. And that light is going to allow those electrons to become excited. Okay, so we're going to excite those electrons. And when we excite those electrons, that's when they can go through that electron transport chain. Purpose of the electron transport chain, remember, is to generate a proton gradient. Once we've generated that proton gradient, through the process of photophosphorylation, we are going to make ATP. Okay, so that's going to be this process of photophosphorylation. Didn't even have enough room to write that there. Photophosphorylation, okay? And when those electrons leave the electron transport chain, okay, so we're going to draw this over here. Those electrons come over here. They're going to be delivered to NADP+, and that's how we generate NADPH through that reduction process. Okay, remember the purpose of that proton gradient is to synthesize that ATP. That ATP is going to be biological money we'll be able to use. And then we've generated that NADPH, which is going to be important as a reductive biocurrency. Okay, so that's what happens. And again, just to highlight and move this down just a little bit so we're not covering our picture here. But this is the chemistry that happens in those light reactions. So this, again, is the light reaction chemistry. So we can sort of see that from this picture here, right? Light reactions are going to generate oxygen, which we have there, generate NADPH and ATP, which we have here. Now we're going to talk about these light independent reactions. So again, light reactions are in red here. These light independent reactions, also referred to as the Calvin cycle, is what we have here. Okay? So we'll put the equation up in just a minute, but to highlight, the Calvin cycle is often called a reductive or a reverse pentose phosphate pathway. So reductive or reverse pentose phosphate pathway. And because that's a lot to write, we'll just remember it as PPP, the pentose phosphate pathway. Okay, so the chemistry that happens with this Calvin cycle chemistry is we're going to be taking NADPH, okay? We're going to be using biological money as ATP. We're going to be taking carbon dioxide. I'm going to So here's the chemistry that happens with these light independent reactions, or we can just refer to it as the Calvin cycle as well, and that might be less confusing. We're going to be taking that NADPH, okay? our ATP, and we're going to take carbon dioxide and fix it into carbohydrates. Okay, so we're going to be fixing, so this is going to be a reduction. Okay, and that's going to be this fixing of carbon dioxide. And then we also are going to get water. Okay, so NADPH is oxidized. Okay, so it's oxidized and it gives its electrons to CO2. We're going to need some money for this process, so we get that from ATP. And to highlight this last little piece, not really important, but you might be like, where does that water come from? This is actually from carbohydrate polymerization. So once we make those carbohydrates and we actually start polymerizing them together, that's where we're going to get water. So just to kind of show how these pieces are connected, this NADPH comes from the light reactions, as does the ATP from that photophosphorylation step. So we can sort of see that with our picture that we have here, that the ATP and NADPH produced from the light reactions get used in the Calvin cycle. Now they just show the products over here from that, okay? But we're using the electrons from NADPH and the money from ATP to glue carbon dioxide molecules together, glue carbon atoms together to ultimately synthesize carbohydrates. Okay, so a nice sort of 30,000 foot view overview here of what happens in both the light reactions and the Calvin cycle, also called the light independent or dark reactions. So just to wrap up, these Calvin cycle chemistries, the light independent reactions, that is this overall equation.